Hello and welcome to Container Bytes. In a previous video, we took a look at GKE GPU sharing strategies that you could use to get more out of your GPUs. In this video, we're going to take a deeper look at one of those strategies, multi-instance GPUs in GKE. Here we have a GKE standard cluster with 3 nodes in it. None of the nodes have any GPU attached to it. We're going to create a new node pool with one node with 8 NVIDIA H100 GPU attached to it. We're going to use the following gcloud command to create a GPU node pool with multi-instance enabled. The key line to focus here is accelerator type NVIDIA H100 80GB, count 8, partitioning size 1G.20 GB, and GPU driver version latest. This dictates how many partitions we're going to create on our 80GB GPU VRAM and what is going to be the size of each of those partitions. Here we can see the different partition size we can have based on the different types of GPU we have available on Google Cloud. On an A140GB, we could have a partition size of 5GB, 10GB, 20GB, and 40GB. And on an H100 80GB, we could have partition size of 10GB all the way going up to 80GB as listed in this document here. The link to this document page will be in the description below. Let's go ahead and create this node pool on our GKE cluster. After some time, we'll see that our node pool has been created. Cube control get nodes will show us that we have a new node that has been created in our node pool. If you do a cube control describe nodes and pass in our name of the node, we'll see that a new node pool description is here. If you look at our allocatable and capacity of GPUs, we'll see that that number is 32, which makes sense because our partition size was 20GB. And in this configuration, each NVIDIA H100 GPU gets hardware partitioned into 4 GPU partitions. How do you go about using this number of GPUs that we have access to now? Let's say you want to deploy a large language model like Gemma 2 billion that would require something along the line of 20-ish gigabytes of GPU memory. Because now we have access to 32 of these GPUs in our single node with 8 GPUs, we could run a number of copies of the same model, or we can run a number of different models that requires that much resource or less. So let's deploy one copy of the Gemma deployment. We have other videos that goes in much more detail about how to go about doing that. We're running one replica and we have defined the resources it would need to run this application. We'll create a Gemma deployment to run on one of these partitions by running kube control apply-f Gemma to be YAML. This will go ahead and deploy and download the image, download the Gemma model from Hugging Face, and run this in one of the partitions that we have. We could watch the status of it by running watch kube control get PO. We'll see that now we're container creating. Now that our deployment is running, we can go ahead and take a look at the logs. To interact with our model, we can just port forward to this service. And the name of the service here is Gemma service. And in a different terminal window, you can run this following request to see that our model is responding. This part already worked in a smaller GPU as well, but because this GPU has been partitioned and now have 32 individual GPUs, let's scale up our service to 24 replicas, and we can do kube control apply-f Gemma 2 billion YAML, and we could watch kube control get PO, all the new pods that are starting up. And all of these new pods will go to Hugging Face and download the model data, and it will be ready to serve. And our service will be then able to load balance every request coming to the service to individual pods. So this way, we could take advantage of our larger GPU and run multiple copies of the application. We could also have run a number of different applications, like different models for different smaller use cases onto the same GPU by using GPU sharing. A couple of caveats to keep in mind when running multi-instance GPUs. Because all the workload run in the same GPU node, you can't really have security vulnerabilities from workload to workload and any noisy neighbor problem. GPU utilization metrics like duty cycles is not available for multi-instance GPUs. Multi-instance GPU splits a physical GPU into discrete instances. These instances are hardware level isolated. A container that uses multi-instance GPU can only have access to a single partition of that GPU and CPU memory. This means a pod can only consume a single multi-instance GPU instance. In this video, we learned how to enable hardware-level partitioning with multi-instance GPU on GKE. In a future video, we're going to take a look at software-defined GPU sharing with MPS and GPU timeshare.